Right. So blood comes down the arteriole, goes through the glomerulus, and then comes out with large things like red blood cells and white blood cells and plasma not going into the nephron. Everything else does. It comes from the glomerulus into the Bowman's capsule. In the Bowman's capsule, toxin and drugs are secreted into it. Solutes like amino acids, glucose, some salt, and potassium all leave, along with bicarbonate. Bicarbonate is then 90% of it is reabsorbed. NH3 and the hydrogen are reabsorbed, are secreted into the proximal tubule to maintain pH levels, and you're going to come down the loop of Henle, and in the descending part of the loop of Henle, water is going to passively leave, and this is going to result in an increase in the osmolarity, and then you're going to go up the loop of Henle, and as you're going up the loop of Henle, salt is going to start to passively leave, and this is going to increase the osmolarity. This is going to decrease the osmolarity, until you come to a point where the salt is going to have to go against the gradient because of concentration gradient. So you're going to need actively pump it out, and then you're going to go into the distal tubule, and in the distal tubule, ammonia and hydrogen are put back in, and that's maintain pH levels. Salt and some of the bicarbonate are gonna exit. Potassium is gonna come back in, and then everything is gonna go to the collecting. Some water and urea is gonna go into the collecting duct and then leave the body. Now, depending on the status of the body and the fluid, depending on if it's dehydrated or there's a lot of blood loss or increase of solute concentration, hormones will also regulate osmolarity, and this is done through things like ADH on RAAS. And what they're going to do, they basically do the same thing where they're going to want to conserve water, so they're going to save some of the water that's being urinated out, and it's going to be reabsorbed.